Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 13.7 entitled Interpreting Stem and Leaf Plots and Histograms. And what we're going to do in this section is we're going to actually make stem and leaf plots, and then we're also going to make histograms for our data sets. And this helps us to organize and display our data and then to make inferences or answer questions based on that data. So a stem and leaf plot is the first of the graphs that we're going to be looking at today. And this is where you put data into a display that organizes the data based on the digits. So you can have the ones place, tens place, hundreds place, etc. So the stem then is going to be the leading digit. So that might be the tens or the hundreds. And by tens place, I mean like the teens, the 20s, the 30s, the 40s. Okay? And then the leaf is going to be the last digits. So if you're dealing with numbers in the 20s, 30s, and 40s, then the leaves would be like the 21, or the 2 part of the 22, or the 3 part of the 23. Okay, so the 20 then would be the stem, and the leaf would be all the other numbers that are after it. So we'll see this in our example in a moment, but if we had the numbers like 20 and 21 and 22 and 23, then the stem is the 20 part, and then the leaf is the 0 and the 1 and the 2 and the 3. So we need to make a key that's going to tell the reader how to read the data in this graph. So that's an important part too, because you're not always organizing numbers that are in the tens place. It might be hundreds or thousands or 10,000s. So let's go through this and let's do an actual example so that way you get a better understanding of what it's supposed to look like. And here we have the number of home runs hit by the 20 baseball players with the best single season batting averages in the major league since 1900. So that's all the numbers that are listed below here. So there's a lot of them. And we're going to make a stem and leaf plot of the data, and then we'll make an educated observation about the data display. So usually when we're organizing our data, we like to put all the numbers into increasing order, and we don't necessarily have to do that here. You can if you want, but that's just extra time. But if you want to be organized and make sure you get all the numbers, you can do that. But with the stem and leaf plot, we don't really have to put everything in order first because we're going to put it in order as we put it into our graph. So you're going to kind of make like a XY table. And the part on the left is going to be the stem, so you're going to label it. And then the other part is going to be the leaf. So you want to make sure you label that as well. So you're always going to have stem and leaf across the top. So then to figure out what type of stem you're going to use, you do have to look at your numbers. And I see some in the teens and some in the 20s, and I see some in the single digits, some in the 30s and the 40s. So when I'm organizing this, I would probably want to make my stem the tens part, and then my leaf will be the single digits or the ones. And since I have some single digits, then I'm technically going to have a stem that starts with 0. 0 would be the stem, and then 8 or 7 or 4, those would be my leaves. And then I'll have to have the teens and the 20s and the 30s, and we went up to the 40s. I don't see any numbers in the 50s. Okay? But when we're making this, we want to make sure we include all of the stems from our smallest number to our biggest number. Okay, so even if I didn't have any numbers in the 30s, I could put the stem there and then just not include any leaves. So now I'm going to go through, and as I go through the list here and look for the numbers, I'm going to cross them off as I go. So my smallest, let's see, I have some 8s, I have some 7s, I have a 4, here I have a 3. So the 3 is my smallest. So when I'm putting in the leaves, I want to put them in increasing order from smallest to biggest. So I have the 3 and the 4, and then I have my 2 7s, and then my 2 8s. And you want to make sure that you're spacing between the numbers, that you're keeping everything nice and neat and organized. And then my teens, let's see, I have a 14, 19, 18. There's another 14. There's a 12. That seems to be my smallest one. So I'll start with the 12. And then I had a couple 14s. So I'm going to put the 4 and the 4. Because I already have the stem down. I have the 1. So now I'm going to put 4. So that way it'll tell people that it's a 14. And then I had an 18. And then another 19 and another 19. So I'm going to have two 19s. Now notice how my leaves, I'm trying to keep them in nice columns as well. I'm trying to keep the rows relatively straight. So we want to make sure this is nice and neat and organized as we're going through here. For the 20s, I have a 21, and then I have a 23, and then I have a 25. So again, I already have the stem of the 20, so then I'm just putting the 1s. And then the 3 for the 30s. Let's see, now that I've crossed off the numbers, it's really easy to see what ones are left over here. So I have a 32, and then I have a 37, and a 39. And then for my 40s, I just have the 41 and the 42. So there we go. So I made my stem and leaf plot, or my graph. And the last thing I need, I have to make sure that I do this. I have to make sure I have a key. And that just tells other mathematicians how to read this information. So I'm just going to pick a random example like the number 14. So I will write 1 and then the line for the stem and leaf plot and then the 4. So that's kind of like how it looks over here in the actual plot. We have the 1 and then a line, and we want to write down what that means. So then we just say that that means 14. And you can really pick any number. You could ideally pick a number that's in the actual graph. I don't think there's a rule that says that you couldn't pick a different number. Sometimes people like to pick the very first one, like 0, 3 means 3, or you could do 1/2, 1, 2 means 12. So it's up to you what number you want to pick, but make sure that you write something down for the key. And then our problem did say that we need to make some educated observations about this data. So some educated observations might be, let's see, that we have more people hitting between 3 and 19 home runs. That's where we seem to have the most people because those are the longest stems. They have the most leaves in them. So that's a good way to organize and group the information visually. So that's an observation that we could make. Just let me write observation. And there's really no right or wrong answer here. So let's see, what did we say? That most people or most players hit between 3 and 19 home runs. Because again, this was the number of home runs that we're going to have. So the number of home runs hit. And since we made an observation about the most, we could also make an observation about the least. Very few people hit 40 or more home runs. That could be an observation. Or you could say only 2 people hit more than 40 home runs. So very few hit more than 40 home runs. And it doesn't say how many observations to make, so I'm just making a couple here. And by educated observation, I mean, that just means that we don't want to just write down any old silly-nilly easy observation. It needs to be thoughtful. It needs to be accurate. So the directions on the worksheet for tonight will say how many observations you need to make. I just wrote a couple of them down here, and we might talk about more than this in class as well. And again, there's not really a right or wrong answer, but you just want to make sure that it's thoughtful, that it's educated. Okay, let's talk about another type of way that we can organize our data then, and this is with a histogram. A histogram is just a special type of a bar graph. And actually you can do histograms on a graphing calculator, but it's a little intense to try and type everything in. But a histogram is basically just a bar graph that displays data from a frequency table. And it represents equal intervals of data. That's kind of the key there when we're dealing with the histogram, is that it has equal intervals of data. So we're going to make sure that each bar is the same size, and we're going to make sure that that bar represents the same amount. So it could be a certain amount of money, or it could be a certain amount of people, or it could be a certain time, like so many months or so many days, but that equal interval is key. And the thing is, we get to choose. We get to choose the interval for the data. And most of the time, you're going to make a tally table. So you're going to make a little table, and you're going to keep a tally. We're actually going to do little tally marks, where you kind of go like that for 5. So we're going to make little tally marks, and we're going to count the data in each of those intervals. And when we make our histogram, again, there's no space between the bars. They're right next to each other. So that's a little bit different than a bar graph. Bar graphs, you have space between them, but histograms, you don't. I'm not sure why. It's probably just because the intervals keep going, that they're constant, one right after the other. And the bars, again, have to be of equal width because we want equal intervals. And the bar length here is going to indicate the frequency. So the length of the bar tells you how many pieces of data are in that interval. So again, let's put this all together in an example. This will be our last example. And here we have the price in dollars of sandwiches at a restaurant. So that's what's in our list here. This is all the different prices of the sandwiches. And we're going to make a histogram of the data. And then we're going to find the probability that a sandwich chosen at random costs $5.50 or more. So that's kind of using the histogram graph to help us review a concept from earlier in the chapter when we were talking about probability. So the first thing we're going to do here is we're going to decide what interval we want to break down this information with. And we're going to make a little chart, kind of like what we did for our stem and leaf graph, but we're just going to do this kind of as side work. So we're going to have our intervals, and then we're going to have our tally. And the intervals, again, we get to decide what they are. So we have to look at our information and think, okay, this is the price of sandwiches. This is dollars and cents. And it seems like, ooh, it's almost all in order here. We've got $4, and then we've got $5. And it seems like the lowest is $4, and then the highest is almost $6. It's $5.99. So a good way to break this down might be in like 50-cent intervals, because it seems like we've got some in the $4 range. Here's $4.50. There's a couple over that. We've got $5.50. So we might want to break it down. And let's start at $4, and then let's go all the way up to $4.49. Let's not go all the way up to $4.50, because that can be our next interval. $4.50 up to $4.99, and then the $5 interval, so that'll go from 5 to $5.49, and then 550 up to 590. So how you make your intervals, sometimes students want to go from 4 to 450 and then 450 to 5. And we've got to make sure that we're, for dollars and cents, if we want to break it into like every kind of a 50-cent increment in the beginning of the interval, then the end of the interval has to end just 1 cent less than that. So that's kind of a new little detail that we have to pay attention to. So now I'm going to see how many of my sandwiches fall into each category. So I have a $4 sandwich. I have another $4 sandwich. $4.25. $4.50 would actually go in the next category. $4.75. Another $4.25. $5.95, so that's way down there. $5.50 is also down there. Another $5.50. And then $5.75. Okay, so now in my first category I have 4, then I have 2 sandwiches, then I don't have any in that category, and then I have 4 there. So again, breaking this information down into these categories really helps me see that I have a lot of fairly inexpensive sandwiches, but then I also have a lot of expensive sandwiches too. Now, I know $5.50 or $6 might not really be that expensive for a sandwich, but if you're looking at this from like a manager's perspective, you might say, whoa, we don't have any sandwiches that are like $5.25. Maybe we need to create some sandwiches that are in that price range for people. Okay. So now that we have our tallying done, oops, forget to cross off my last dollar amount there. Now that we have the tally done, now I can go ahead and I can make the actual histogram. And so this part over here is going to be my actual histogram. So the tally table and the interval table, that's just a little bit of work to help us get organized to make our histogram. And we need a title for our histogram, of course. So let's call this sandwich prices, since that's what we're graphing here. Oops, I was going to make it plural. Sandwiches. Let's just do sandwich prices. Okay, so we have sandwich prices. And we're going, let's see, across the bottom here, this is going to be my intervals. And I broke my intervals down in by price. So that's what I'm going to put across the bottom here is my price. And then I had 4 categories here. So I've got my first category, second category, third, my fourth. And so then I want to label this as 4 to 449. And then my next was 450 to 499. I want to kind of do this nice and neat. And then I have the $5 to 549. And then the 550 to 599. And for our price, we would definitely want to say how the price was being measured. So we'd want to say in dollars. And then the most that I had here for my total number. So this was my number of sandwiches. Okay, so across the side here, I'll put number of sandwiches. Okay, the most I had was 4. So 1, 2, 3, 4. I'm going to label those all. Okay, now when I make my bars, remember I have to make them of equal width and they have to be right next to each other. So this 449, 4 to 449, let's say I had 4 in there. I have to try and make them equal width. And then my next one, I had 2. So the bar is going to go right next to it. So I want to try and get those tally marks like in the middle of the bar. And then my next category, I didn't have any, so I'm going to leave that empty. And then in my last one again, I had 4. So I'm going to try and go up the same height as the other one. Try and make it the same width. And if you want to shade them, you can color them in just like you would a normal bar graph. That's fine. And if you want to use different colors, you can use different colors. But again, this is just a way to visually represent the data. And you can see that at the low end here in the $4, less than $4.50 range, I've got a lot of sandwiches. And more than $5.50, I've got a lot of sandwiches. But in the middle here, there's not much. And again, there's a huge lack right here in the low 5 to 5.49 price range. Okay. So that could be an observation. If they were asking us to make an observation about this data, we could say that there aren't any sandwiches between 5 and 5.49. But they asked us to find the probability that a sandwich chosen at random costs $5.50 or more. So to find that probability, here's our work for our probability that they asked us to find. The $5.50 or more. Right here in my $5.50 or more category, I've got 4 sandwiches. And that's what I want out of the total. So the total, let's see, I had 4, 5, 6, so that's 10 sandwiches. So I had 4 out of 10. And we could reduce that down to 2/5, or you could write it as a decimal. You could say 0.4. So there's a 40% chance of getting a sandwich in that category. Okay, so practice these types of graphs on the worksheet. You might need some extra paper if you want. You don't have to put all your work right onto the worksheet. You can put it on a separate piece of paper if you need more room. And they're going to ask you some questions about the histograms and the stem and leaf plots as well. So it's not just making them, but it's also making sure that you can use that information and answer questions about it. So again, if you have any questions, come on in and see me before school.